I want to say hello to everybody. This is another educational video that we are putting on as a joint effort with Seminole County, with the Florida Roofing and Sheet Metal Association, also with GOBA, and we have our representatives here, and we all would like to at this time introduce ourselves before we get started on this educational video on a residential re-roof application. So I am the building official. My name is Bob Pike for Seminole County, and to my right,
it's Mike Silvers, Technical Director of the Florida Roofing and Sheet Metal Contractors Association. I'm also a state certified roofing contractor and have been a contractor for over 40 years in Florida.
Robert Wormley with Wormley Roofing, the president.
Ricardo Rodriguez with Greater Orlando Builders Association. I'm the Government and Industry Relations Advisor for GOBA.
Lisa Pate with FRSA, Florida Roofing and Sheet Metal Contractors Association. I'm the Executive Director.
And with that, thank you very much. We're very pleased to see all of y'all here, and we're extremely happy to put this video on. So with that, we'll go ahead and start. Obviously, re-roofing in Florida requires a permit, and in Seminole County, we require a permit, and this is a copy of the permit that our roofer has gotten. And with those requirements, with Seminole County, we also have a product approval form that goes with that indicates information on the roof, the type of roofing that they're doing, the existing roof structure, the slope, and the products that are being used. It also contains the product approval numbers for the asphalt shingles. It also includes the product approval for the underlayment, and also for the ridge vents. Any attic vents requires the product approvals, and we have those numbers, and we have the skylight and information as well, which also is required by the state of Florida for product approval. And with that, the contractor supplies the manufacturer specs on site for the inspector. So our sheet just indicates what they're using, and then the manufacturer provides the specs. The code requires to be done to the code. Also requires the product approval, and also to be done by the manufacturer's installation instructions. So with that, we'll turn this over to Mike as to the requirements for the product approvals, and he'll talk a little bit about that.
In Florida, you can meet the requirement for product approvals, and most roofing products require a product approval from one of two entities: a product approval through the state of Florida, the Florida Building Commission, or an NOA, that's a notice of acceptance, through Miami-Dade County. Something, if you do use an NOA from Miami-Dade County, you have to realize that there's requirements that they have there that are called RASs. That's a roofing application standard. If a roofing application standard is mentioned in the NOA that you use, you have to follow that as well. For instance, in Miami-Dade, you have to use 10 tabs and roofing nails instead of a cap nail that's used in most of the other counties in Florida, other than Miami-Dade and Broward. So if you use an NOA for your product approval, you have to follow the RAS and use 10 tabs and nails. And that's just a for instance. There are other RASs that are associated with NOAs, and they go together. The code requires that you follow manufacturer's installation instructions and the code. If there's a conflict between the two, you have to use whichever is more stringent. So that, because it's basically a minimum building code, if the product manufacturer wants you to exceed that, then you've got to go ahead and do more than what the code requires if the product manufacturer says that that's what they've got, and that's the way they tested for their product approval, or NOA, which is really the dictating document of how you have to install the products in Florida.
Mike, that's a good point. The materials that are being used for this installation, do we want to kind of go over those as to what he's doing? We did talk a little bit about that on the re-roof supplement form, where the contractor wrote down his project approval numbers, and it's his responsibility, which he has done, to print out the product approval installation requirements as well as the manufacturer's installation instructions. And then we also have the code requirements that also come into play. So as you were saying earlier, whichever is the most stringent, that has to apply. So the contractor really needs to know his application and how to properly install and get through permitting and to do the proper installation. There's a lot involved. And so we find common mistakes that are being made daily because, you know, maybe somebody in the office is making a mistake and it gets out on the site and it's not the correct product approval or matches the product, and then the inspector has an issue with that. So it's very important to make sure that we have everything in order to get it through permitting and have it out on site for the inspector, because this is a one-day job to strip it, to re-nail it, to underlame it, and then flash it. So it's a full day job doing that, and then second part, our video will come and we'll do a final inspection. So, but today we want to get involved in that, and Mike's going to go over the requirements that they've submitted for the installation that they're using.
Let's start. A good example of the difference between the manufacturer's requirements and the code and the product approval is they're going to use a Summit 60 synthetic underlayment, which is produced by Atlas. Atlas, of course, makes this product to be used all over the country. So their nailing requirements are pretty much a minimum for that particular product to be used anywhere in the country. So what we have to do in Florida, we have an underlayment table that has some very specific nailing patterns that have to be used. So when you look at the Summit installation instructions, they have a certain nailing pattern. It doesn't have as many nails as are required in Florida. So for Florida, you have to go to the underlayment table and make sure that you're using the same number of fasteners per 100 square feet, or what we call a roofing square, as are required by the table, whether the manufacturer's installation instructions call for that many nails or not. And that's an example of how Florida differs from other areas of the country. The shingles that they're using are an Atlas shingle as well. And they are going to be, I'm looking for the brand of shingle or the product line. Do you recall what those are right off the top of your head?
The Pinnacles.
The Pinnacles, yes, Atlas Pinnacle shingles, and this is the product approval for them. Again, there are nailing instructions that come with the product approval, the way that it's been tested for Florida, and you've got to follow those, not just the manufacturer's installation instructions, the same way as we talked about the underlayment. And you have to have one of these for each of the products that requires it. There are some products, roofing products, that don't require a specific product approval. Small vents, lead boots for plumbing stacks are a couple of examples, but there are some others. The items that have to have product approval are listed in the building code. And as far as ventilation is concerned, it's attic ventilation that has to have product approval in Florida.
Great point there, Mike. When we were talking about the underlayment and the cladding, the shingles, we have code requirements for that. And I think in the paperwork there we have the requirements for the building code. And first of all, the existing building code, this is obviously an existing home, so this would fall under the existing building code to start. And the existing building code refers to new installation methods, and products have to comply with the Florida Building Code. And this is the Florida Building Code residential, because this is a residence, single-family home. So with that, I've printed off a copy of what the code requires, and we have a table here showing the wind speed requirements for asphalt shingles. And so for our wind zone, we are actually 139 is our worst case in Seminole County. So we do interpolate if somebody wants to interpolate, but it still falls into the slot. We're not going to interpolate below 129, which be the lower category. So mostly Mike had interpolated here through the engineering website that they use, and it comes to 134. So by that we're using the 142 table, and you can see that that requires ASTM-D type G or type H shingle, or an ASTM-D type F. And with that, the product approval for that product that they are using meets that standard. This is part of the product approval that shows that they do meet that standard, 3161 Class F and ASTM-D 7158 Class H. So they have selected the proper shingles for our wind zone. That's very important. And now the other thing with the code requirement is now the underlayment. We now have an underlayment table that's required. And this is a requirement showing that the roof pitch, they're using asphalt shingles, and they're showing that the roof pitch is between a 2 and a 412. And Robert, what's the pitch on this roof?
It's actually a 512.
Okay, so it's a 512, so he's actually better. So he's using, you can see that this is, for this type, it calls for a, gives you the ASTM requirements, type 1 to 226, or ASTM 4869 type 1, type 3, or type 4. And then for 412 and greater, the underlayment requires a ASTM-D 226 type 2, an ASTM-D 4869 type 4, or an ASTM-D 6757. So he would apply under this section right here, and that's what he has done with his synthetic. So with that, I'll turn that over now back to Mike, and he can talk a little bit about the synthetic and the other product approval requirements.
Keep in mind, when we talked about finding the wind speed, here in Seminole County, they allow you to interpolate, and what that is talking about is on the wind maps that we have to follow, there are lines that are called contour lines that run through the state of Florida, for that matter through the whole country, but we're talking about Florida. And those contour lines, for instance, one may be 130 at the lower side, which is typically to the north here in Florida, and it may be 140 at the high side. Here we can interpolate. We came up with 134 because we're in between those contour lines. Keep in mind, some counties, in order to make it simpler for their inspectors, will pick up the highest mile per hour that applies to their county and apply that to the entire county. So even if you've got a line coming through the northern part of the county that would allow you to use lesser wind speeds, some counties require you to use the highest wind speed in the county. So that depends on your authority having jurisdiction, which typically is your building code official or your code official, who will make that determination through his department. The thing with, again, we talked about a little bit before with the underlayments. In this particular underlayment, this is a 4-foot wide roll. Most of the standard underlayments we've used in Florida for years are a 3-foot wide roll. So the table in Florida says you need to nail those underlayments 6 inches on center at the lap, and 2 rows in the field 12 inches apart, and the nails 12 inches apart and staggered. Well, because the manufacturer's instructions here for a 48-inch roll, and they only have 1 row in the center of the field, we've got to match now the table, which means for that 48-inch wide roll, we're going to have to do 6 inches on the lap and 3 rows in the middle at 12 inches on center. So we've actually, because we're in Florida, had to add an additional 2 rows of fasteners, more than what the manufacturer's requirements call for. And that is in order to meet the table. And again, it's real important that if there's a conflict between the code and the table, you have to do the code and the manufacturer's written specifications, you have to do whichever one is more stringent, because you have to comply with both. And it gets a little confusing for roofers, and it's gotten to where it's quite confusing. A lot of that has to do with product approval. Once it was turned over, instead of having a prescriptive method in the code that told you how to install everything, it came down to the manufacturers test it, and that's the way you have to install the product, because that's the way it's been tested. Think of anything else that I've missed there?
You did a great job on that. And then they're using obviously the synthetic, which a lot of roofers now use. It's a pretty quick, fast method of doing that versus rolling out the felt and then lapping it with low slope roofs, meaning in between a 2 and a 4, they would have to use a 19-inch lap, which is a lot of roofers call a half lap, but it's really a 19-inch lap because of the low slope, to keep water from cavitating back up and get up underneath and get the deck wet. So the other product approvals that he has submitted, Mike, is he's showing for, what's he showing for venting?
They've got a Cobra vent that's made by GAF,
Okay.
and they have product approval for that.
Perfect.
And as we talked about before, also for the low slope roof, there's a variation. Shingles are really the only roofing product that are where you look for the installation method based on wind speed. The rest of the roofing products, including the flat roof on the back of this house, have to go by wind pressures. So you actually have to do some calculating or pull that from an engineering site that'll give you the uplift pressures for this particular building. And then you've got to go and match those pressures with the product approval, which has been done here. They've got a product, and again, they have to put more nails than would be typically done according to the manufacturer's instructions, because the product in Florida requires that. They've got to put 4 rows in between a 36-inch material, 6 inches on the lap and 4 rows at 12 inches in the field. And that will change depending on the thickness of your plywood. A 15/32 plywood is going to require quite a few more nails than a 19/32, which is what we used to refer to as 1/2 inch and 5/8, but that's nominal. So you've got to watch that if you know you're dealing with a 19/32 deck, that you're going to probably have to have more fasteners. We run across from time to time some houses that have 3/8 inch plywood on them. Some shingle manufacturers have product approval for 3/8 inch plywood, and that's because shingles are tested a little different than other things. You won't find low slope roofing applications, typically any product approval on those over 3/8 inch sheathing. So if you find 3/8 sheathing on a low slope roof, it pretty much has to be replaced in order to meet the product approval, because it's only been tested over 19/32, not 3/8.
Great point. Great point. Mike, also we're using, it looks like he has a Kennedy skylight that he has submitted product approval for, and that will also be a requirement for the inspector, the installation instructions, so they know how to inspect that for its fastening.
Those, for skylights, that's very similar to, you're in the same section of the code as fenestration, which is your windows and doors, and they have to be impact resistant. So that's in their product approval as well for the skylights. The low slope roofing that they've chosen is a CertainTeed product. They're using a 3-ply system, which is a real nice system. It's a base sheet, a specific base sheet made for the peel and stick products, nailed. Then a inner ply, which is a self-adhering, where you take off a lot of people call peel and stick. That's a smooth peel and stick, that's the middle layer, and then they'll come back with a granulated peel and stick on top of that. And all of these products are made and compatible with each other and are part of a specification from CertainTeed, the manufacturer, and again, that has product approval for different wind uplift requirements, and they'll give you nailing patterns based on that.
And that's the product that we're using for the flat roof is
CertainTeed.
is the CertainTeed product
Yes.
as well. Okay, this house has a little bit of everything that we'd like to talk about. We have a pitched roof. We have some. We have a flat roof on the back. We have a skylight, and also this house originally came with off-ridge vents. And so I believe Robert is going to replace those off-ridge vents, board them up, and go with one continual ridge vent, which would increase the ventilation of that roof. So that's a good thing that he's doing. I believe he's going to replace the eave flashing. Is that correct, Robert? Correct. Yep. So he'll replace all the eave flashing. And we can see that this house has siding on it for a little pitched up roof. So you'll see the wall siding, and underneath that siding has L flashing. And of course the roofer is not going to replace the siding. That would take a building contractor to do that. So more than likely, as long as the L flashing's good, they're going to reuse that, and there's a method of reusing that and applying the the methods for sealing that and applying the underlayment goes underneath it, and how Mike's going to talk about that as we get up there and go through that. And we also have some valleys on this roof, so this roof has a little bit of everything. So we're going to start out and go around and walk around it, and Mike can talk about it, and he can point out some things, and I will interject, and then eventually we'll get on the roof and look at the deck nailing, the underlayment, and the flashing that's installed. Also, we're going to look at the flat roof, proper installation, and we are going to look at the skylight installation, so and also the valley installation. So I look forward to that, and we're going to walk around, and Mike, you're going to take the lead on this, and we look forward to learning a lot with you.
Okay. Let's start over here. In the Florida Building Code, it calls for flashings to be installed anywhere that the roof has an interruption or a termination. So that basically means that all of your edges, anytime anything comes to interrupt your roof, and there's a great example of that, this little eyebrow that's down here up underneath of the overhang. That would be, there's several things going on. You've got an interruption, which is the wall. You've got an interruption on the side, which is where the soffit comes down and meets your roof. And then you have a termination where the eave drip is. All of those require flashing. In Florida, we have some very specific thicknesses and material types that can be used for flashing. There's a table in the residential code as well as the building code that calls out the types of materials that can be used for flashing, metal flashings, and the minimum thicknesses for those metal flashings. And that's important. Even if you're going to reuse the flashing, you're still supposed to have that minimum thickness that's in those tables. And that's something that's pretty important. We talked about this, a common condition we see along the eave of the roof, that long edge where the water drips off. It's very common for the fascia on that eave to have been run sometimes above the sheathing being the main deck that has slope. What will happen is the trusses or the rafters will run up and down a little bit because they're not perfectly straight. They want their fascia to run straight, so they run it straight. And so there are times when the fascia is higher than the roof deck. And if you use a thin eave drip that has a narrow flange, sometimes that eave drip sits flat. Well, the minimum slope for shingle roofs and the type of materials we're using on this roof are 2 and 12. So if that eave drip flange gets below 2 and 12, it doesn't comply with the code. Robert's done a good job of bringing in an extra wide eave drip. It's got a 4-inch flange on it, and what that'll do is span over that place where the fascia, I almost need my hands to talk about,
not a problem,
where the fascia is above the sheathing like this. So what he's doing is using a wider flange to bridge that and keep the proper slope. That's a common mistake, and we see it create a lot of problems. You tear off your roof and there'll be rot all along that eave edge because of that. Very important. And then there's some specific requirements for how you do those shingles, but we'll talk about that when we get up on the roof.
Interjecting a little bit on what Mike was saying, here we have an instance where this is the eave flashing, or eave drip as they call it, and underneath it, if you can see up under here, there's a 1x, okay? And because the code requires the flange on the eave drip to be on to the decking 2 inches. So if this has a 3/4 inch 1x there, which extends out, so as Mike, as you were saying, they have to use a 3-inch flange on that.
Right, and the 1x could count as part of the decking because it's solid wood, but if you notice, the eave drip is leaning a little bit like this. It's staying 90 degrees off of the roof plane, and what that does is that eave drip is not tight up against that freeze board or that 1x2 that's underneath there. So there's a gap, and of course that gap caused the eave drip flange to come down off of the slope some, so you're not getting that full 2 inches that's required to be onto the roof plane. It's actually got a gap, and if you look down through here in places, you can see that gap.
Perfect.
So that's something that you want to stay away from, and again, that wide eave drip helps with that.
Exactly, and here we see on the eyebrow, Robert, you wanted to talk a little bit about that, on the type of installation you were going to do back on that.
Yeah, one time they must have eliminated the 1x 2, which is not allowing it to be able to seal at the end. We'll be adding back that 1x2, so we're able to take and turn and be able to seal that corner properly.
You can see that's open right on this end. And as water runs down this rake, what we call a rake on this end of this gable, a lot of that water, by the time it gets down to here, will be pouring off the side and running up underneath this condition. So it's very important that that's sealed properly.
We are now at the back of the house. As you can see, that the roofers are taking the cladding off and the underlayment. So now we come back here and we see the eave flashing that we have here. This is actually the rake flashing that's going up. And this is a good spot here where Mike can talk about this type of flashing and how it was installed at the time that it was done.
We talked about on the front of the house that the code requirement in Florida is that this flange, this vertical flange, rest on the wood a minimum of 2 inches. And if you can see, oops, excuse me, that flange from this back side, which is where it's supposed to be measured for how much it laps onto the wood, is exactly 2 inches. So up front, where we had a gap in between here because of the way the metal hangs over the edge, there was a gap probably about as thick as my finger there. So we got less than the 2 inches on the deck. So this actually, when it was installed, did not meet the current requirements in the building code. So that's why Roberts ordered a special eave drip with a wider flange. And that's really important on residential re-roofing. I think that roofers, by and large, should try to do that when they can. It's not a code requirement, but the 2 inches back onto the roof is a code requirement. So that's important. And then the number of nails are another item that is important. We typically want to nail those eave drips in this wind speed at 4 inches on center. Correct. Most of your metal flashings, by and large, will get nailed 4 inches on center.
Correct. Now on the front, because of the pitch on that, and they had put the 1x on that, and that's why it was difficult to get the face of the eave drip up against the downward flange on that. So as Mike was talking, because of the pitch down in the 1x, they were off by about a finger, which only left less than the 2 inches that's required. So that's why a problem we were having at the front. So this is a great spot here to talk about that situation, and also here on this situation as well.
One of the most common problems that we see out there with shingle applications are the eave drips that don't have the proper lap onto the roof, and thereby often don't have the proper slope on the eave drip.
We made it onto the roof deck now. We're on the flat roof portion, and Mike wants to talk. As we came up, we saw that the rear has gutters, and that's always a problem in re-roofing. So a lot of times they'll want to leave the gutters because the roofer will say he's not responsible for that. Other times the roofer will take it off and then reapply it back after he puts the eave flashing on or eave drip. So with that, I'll leave that in to Mike, and he can talk about that.
So what we're going to do, we're looking at a place where it's done like I would not like to see it done. What's happened is here, the gutter's here. It's in place. They've re-roofed over it. Not these folks. The people who previously roofed it have roofed over the gutter. And when they did so, they took in this case, this is a drip edge. Again, very similar to the eave drip, but now we're on a low slope roof, so it becomes a drip edge because this is not an eave, it's an edge. But what they've done when they roofed over this, they left the old drip edge underneath, which creates some problems. It makes this edge higher than the rest of the plane of the roof. So you may have ponding right back here because this edge is thicker and created a bit of a dam. So that metal should really come off when this is done. And what they've done when they ran their new metal, they cut this notch. And of course, water comes off here as much as it does anywhere else. And when it runs and hits this notch, now the water can run in and get in behind this metal. And typically there's not a secondary metal to try to keep some of that out, which it'll do to some degree, but you're still letting a lot of water in this area. So the proper way to do this is to remove this spike and the ferrule, put your metal in, and then put the spike and ferrule back in place again. And if we can, in a minute, I'll show you one that's been done properly that happens to be on the same house, so that's kind of convenient. So we'll get that from a different angle in just a second.
As Mike was talking, they've lapped over the existing eave flashing and not replaced it. So this is the one that they installed over. You can see that they've cut that up, and because they didn't want to remove the gutter, the existing nail has gone through the existing eave flashing. They've gone over it, and because they didn't take it off, they had to cut it to install the new. And there's a code requirement on that, and Mike, let's talk about that.
That code says that the vertical flange of that metal needs to extend a minimum of 1/2 inch below the bottom of the sheathing, your decking material. This is some pretty thick decking material. It happens to be 2 by tongue and groove, so it's at least 1.5 inches thick. So when they've notched this high, which is clearly only it's only 3/4 of an inch below this nose, that's not getting you down to that 1/2 inch below the sheathing, because we've got the sheathing in this case is 1.5 inches, plus you've got some thickness of material. So you would need to be down, in this case, over 2 inches down here in order to be where you're supposed to be, and they're nowhere near it once they notch that. And the code doesn't care whether it's notched or it's the material. It still says it's got to come down 1/2 inch below the bottom of the sheathing, regardless of the thickness. And in this case, we've got a very thick sheathing. But even on a plywood deck, that would still be not, that part of the eave drift, this part right here, would not extend down far enough to comply. Here you can see, even though this is on the same little area, here it's done the way it should be. The gutter spike has been removed. The ferrule, which is this piece here, has been removed. The eave drip has been installed, and this is put back in place. So all of the eave drip extends down to that dimension, 1/2 inch, at least 1/2 inch below the sheathing. And that's the way you want to handle this, not by notching the face of your new metal.
So that does meet code compliance.
That's correct.
Correct. Okay. We're back to the pitched roof area now that we're talking here. So we're going to talk a little bit about deck nailing. Obviously this was some broken wood here, so the roofer is going to replace that. There was an off-ridge vent up here that he's going to replace and deck that in and do a continuous ridge vent all the way across. Will give them more ventilation area, which is a better insulation for that. So here we are. We have some 1x decking here, and Michael, let's let you go ahead and talk about that. And Robert, you might want to pull out a nail to see what it was existing nail-wise. And I think you've done that earlier, and I think you actually gave me the nails. So with this, I think it's that one. This is the one that was taken out. And this is number 8. It was 2.5 inches long, I believe, right?
Yes.
And the code requires, I believe, 2 3/8. So this is the proper nail with the code requirement. As long as they have 2 of these existing nails in that 1x, then they do not have to re-nail. So, and they have 3 in each board. So they are code compliant with this and do not have to re-nail this. Go ahead.
I didn't mean. Quite often in Florida, we're dealing with plywood decking, and on plywood decking, it has to be re-nailed 6 inches on center with an 8D ring shank nail. But there is a table in the code, in the residential section, roofing section, chapter 9. There's a table that tells you how you count your existing nails. And if you've got a round head, 8D, smooth or ring shank in the proper location, then you don't have to re-nail it with the 8D ring shank nail. This has a round head, as Bob showed you the nail. The head on it is a round head, not a T head, so it counts. And again, since it's 6 inches on center, if you had 2 in a 1x12, that would give you your 6 inches on center. They actually have 3. An important point for roofers is when you have a situation like this and you have to replace the sheathing, whether it's plywood or in this case 1x, and you've got an opening like this, you have to keep in mind that you need to go, and I'm going to step up here where I can show you better. Anytime you're replacing sheathing, you have to go over 3 supporting members. So you'd have from here to here to here at a minimum. And what that means is before they sheathe this in, they've got to cut some more of this out and come over to the next support member. Why that is when you step on this and load this opening, there's actually some of the force gets transferred over to trying to lift this piece. And if you only span one, that wood will bow, and it'll eventually, you can either step through it, or in time it may just bow from hanging there, and you'll end up with a dip in your roof. So you've got to do 2 spaces, 3 members anytime you're replacing sheathing on any roof that's flat or steep slope, I should say. Again, with this type of 1x sheathing, you end up with some gaps, and this is natural. Some of it's from drying of the wood, and they have to leave a little space between them when they're installed, but you end up with some gaps. As you shingle this roof and you start at the bottom and go up, you have a specific exposure, how much of the shingle is going to be out and how much is lapped underneath, typically around 5.5 inches. I'd have to look at this particular shingle to see what the exposure is. But what can happen if you follow that exposure that's recommended all the way up this roof, you can end up with where you need to put a nail line being right in the middle of one of these cracks. So that means you've either got to take your nail and move it in the shingle, and with a laminated shingle like is on here now and will be used, there's a place where the 2 shingles lap over each other. You need to maintain your nail in that double lap because that's what helps to hold everything into place. Sometimes you work up and you find your nail's going to drop in this hole, so you either have to move the nail, and sometimes to move it far enough out of this hole, you end up coming out of that laminate strip. So what you have to do is reset your course. Where the course may say it needs to expose 5.5 inches, you may need to drop that down to 5 in order to place your nail and your laminate strip in the right position. It's not less than required by the code because you're actually lapping the shingle more than it's called to be lapped. So that's something that comes up. Some people have an issue with it because you'll be able to lift the bottom edge of that shingle just a little bit because it's lapped over. So if you have to lap this shingle, thank you, Robert. If you have to lap this shingle, see our seal strip here? If in order to get that nail in the right place, if you were putting it there, we might be in the gap. So let's say we bring it down 1 inch, okay? And we bring it down 1 inch, that puts our nail where we need it, but it also moves us just a little bit out of this drip strip. I don't consider that to be not compliant with the code. Again, you're overlapping it more than it's required to, and on a sheathing like this, sometimes you just have to do it. It's the only proper way to get the nail in, and given the 2 options, much better to get your nail in the right placement into real wood and have that little additional overlap.
So going back with that, Mike, the roofer really needs to know where his stagger is on his decking in order to run his rows of shingles, so we don't have that nailing in the crack scenario. So it's good to determine that before we even apply the underlayment on the roof. So I'm glad you talked about that. That's a great point. A lot of issues come with that. So
as long as you run your shingles out and they're basically asked to be installed that way, you run each course. Now you don't have to run it clear to the edge of the roof, but you have to keep each course running continuously. So as you start to lay that first shingle from the left heading to the right, if you go to nail that and you're in that gap, now you know you're in the gap, so now you've got to say, okay, I've either got to move it, you can't move it up because that would expose all of this. So now the question is, how far do I have to move it down? You correct it in that 1 course of shingles, and then you start laying them up again to the recommended exposure until you run into that situation again. And on a deck like this, you're going to hit that probably by the time they get from the bottom here to the top. They might run into that condition 4 or 5 times and have to adjust that exposure accordingly. And it's just, there's nothing you can do about it. You have to do it. Very important with these shingles that you nail this shingle, and the manufacturer's instructions will show you where, but if you look real close, right here is where those shingles are laminated together. And that's where that nail needs to go through.
2-part shingles. So.
Right. Yeah, this and this are 2 separate pieces. You see this is part of it. And this part here is just a little strip. Very well glued, but it's a separate strip. So if you don't get your nail through both of them, you're not holding the shingle together like you should.
So basically, the nail has to go through the overlap into the underlap to properly nail that and secure that. So you have that much of an area to proper nail that shingle in. Some manufacturers will give you a little line, 2 lines there to nail in between. So basically looking at the wrapper will tell you how to properly fasten the shingle.
Some of the shingles, actually, this little strip here is separate, and it can peel off. You don't have to peel it off, it will. Some people think that that's a release strip that you have to tear off. Has nothing to do with your installation of your shingle. That just stops them from sticking together in the bundle. So whether this has or hasn't been peeled off has no effect at all in the installed roof.
Okay, Mike, on this side, the roof deck is, they've used plywood on this side. So with that, there's a little bit different requirements for that. So this is an existing nail that the roofer had taken off. It looks like it's close to being proper, but after measuring it, it is the proper length. It just the shank is improper. It's not thick enough. So with that, with the scale that we use, this was a .125 shank, and now that tells us that that was nailed incorrectly. And now we've checked the roofer's supply that he's using for this roof, and it is a .135 shank, which does meet the code requirement. And so he will be re-nailing this plywood deck. And Mike, with that, what's the requirements for that?
Yeah, you need to use, again, the 8D ring shank nail, which all of the dimensions are listed in the building code. And they need to be nailed at each supporting member, 6 inches on center. And if there's old nails that don't comply, you basically ignore those and re-nail it with new nails, 6 inches on center. And this one has been re-nailed several times, but unfortunately not with the nail that is required currently. So you have to just basically ignore those nails and go ahead and add the new nails at 6 inches on center.
Great point, thank you. Okay, now we're back on the flat roof, and we're going to talk about the nailing portion on this area of the roof deck. Mike, this is a 2x decking, and the supports are look like they're about 4 feet apart. So we've had the roofer remove one of the nails, and this is obviously a number 10 or a 12. So this more than meets code compliance because, Mike, what's the code requirement on that?
Again, it's an 8D ring shank nail, but you may have to have a longer nail because of the 2x. So it's a good idea. They've stepped up to probably a 10 or a 12.
Right.
I'd have to mic that and measure it to be sure. But you still have to add another nail because they've only got 1 nail in each structural member, and it requires a minimum of 2.
Great point.
So they should add an additional nail where these nails are. They can count this one because it's clearly more than what code requires, but they need to add another one to get 2 at each structural member underneath. In this case, it's a ceiling joist or a roof joist.
Now there's a situation here that I've noticed, and here we see some tapered insulation board here. So let's talk about that, Mike.
Okay. Yeah, when we looked at this job a week or so ago, Robert had pointed out that at some point someone ran a conduit above this finished ceiling. The reason why, this is, as we said earlier, 1x tongue and groove decking, and that has a real nice look, and it's finished inside. So you're going to see the beams that run the structural members, the joist or rafters that run down through here when you look up. So there's a couple of things. One, you got to be real careful not to have your nails come through this because it's finished underneath, and if you put your nail through it, it's going to show up. So it's real important that when you're putting those nails in, you hit that structural member. It's also very important that you use the right length nail when you're re-nailing the dry-end, the base sheet for this. The code requires that the nail either penetrate through the sheathing, which here, of course, you don't want to do that because it's finished on the other side, or a minimum of 3/4 of an inch into the sheathing. The good news here, it's 1.5 inches. They can use a nail that's 1 inch longer, like 1.25 inch nail would make up for the roofing material. Even a 1-inch nail would make up for the roofing material and be a full 3/4 of an inch into this wood. Not through it, but 3/4 of an inch into, because this wood is thick enough that you don't have to penetrate it.
Excellent. Mike, I've noticed that they don't have enough fasteners in the tapered insulation board, so they got to come back and finish fastening that
they're quite done.
per the product approval requirement.
What they've done here is because of this conduit being ran on top of the roof, they would really, there's two options, that they either reroute this, and there's no place to put it inside where it wouldn't show. So you would have it running across your finished nice wood ceiling, you'd have a conduit. So it was ran on top. You don't want to run your roofing directly over this. So what they've done is they've used some tapered insulation, and they've created a nice transition from their flat roof onto this, and allows them to run their roofing material across here without laying directly on that conduit and deforming their roofing material. So this is a good way to handle an existing situation. Much better not to have the conduit on the roof, but the roofing contractor didn't get to pick that. He's got to figure out a way to properly roof it and leave the conduit in place, and that's what they're doing with the tapered edge board.
So they will come back and finish fastening this with the proper nailing pattern with the plates, and then they're going to go over this with a, you're using a peel and stick product over this?
Putting the nail base.
Putting your nail base, which is part of your product
fasteners.
approval for your bitumen roofing. So you're going to put your nail base on, and then you're going to put your cap sheet on top of
The
that.
mid-ply and then the cap.
Mid-ply and then a cap. So.
And because of this little step here, and again, this isn't necessarily a code requirement per se, it's just trying to do a good, you're making a little step as it is. So my suggestion would be is to take a strip of the base sheet before you roll out your base sheet and run a strip over that and over this to reinforce those spots before you roll out your full mechanically attached or nailed base sheet. And that kind of helps to bridge some of this and makes the transition smoother for your final roofing material.
Perfect. This one has a great, a lot of stuff on it that's great to talk about, and we run into these situations because this is an existing installation. This is very difficult for roofers to have to deal with because a lot of times, you know, this is an existing installation. They're bound by that. Otherwise, they're not electrical contractors to pull that out and redo it underneath the roof deck. So a great point on how to deal with that. So, and as we hear, we have some existing flashing here. And Robert, what are you going to do with that?
Imagine you're going to leave that in place.
That we're going to do to the transition to keep it smooth, correct? We'll clean it up.
Mike, they can reuse that since it looks like it's in good shape.
Sure, and the idea is kind of like what we talked about here with having the additional layer of base sheet. This is helping to make this transition between this material and this material, and it helps to smooth it back out again. They'll probably add some nails, make sure they get that laying down nice and flat. Again, I would suggest laying an additional piece of base sheet over that before they put the one down that they're actually using for their anchor sheet for their 3-layer system. Anytime you've got a rough condition, always a good idea to put a dummy sheet down. Again, not necessarily a code requirement, but a good solid roofing practice. And there are a lot of roofers out here that are very interested in not only complying with the code, which is very important, but also making sure they get a good watertight roof on, which is the primary thing we're doing out here.
Let's talk about underlayment for this. I'm assuming they would need to put the underlayment on the flat roof deck and run it up the pitched. I'm assuming that's correct, Mike, Robert, and what you're going to do there? You're going to do the underlayment, the base sheet, the mid-ply, and run that up. How far are you running up? 16 inches?
Code 16 inches from pitch break.
And then he'll come back on his pitched roof underlayment and he'll go over that. So it'll shed over that. So water will not get up underneath the flat roof section. So we're not quite there yet as they're taking off the roof, but once they go through and re-nail this flat roof area, then they'll clean it up and then go to do they'll fasten the tapered insulation board down proper, and then he'll run his base and then his mid-ply, and it'll be up the pitched roof area. So they'll be ready for that pitched roof area once they get it nailed and dried in to overlap that. So anything else you want to add on that?
Yeah, important when they're running, in this case, they're running a 3-ply system, which is going to have some thickness to it. As they run those different layers of material, and here you're actually going to have, if he puts that dummy base sheet in, that would be one. plus your 3-ply, and then a piece there for a flashing to reinforce what is a interruption in the slope. This change of slope is considered an interruption and has to have another layer. So at this point, coming up into here, you're going to have as many as a minimum of 4 with a 3-ply system, because you've got 4 counting the flashing, and if he puts the dummy sheet underneath, then he's going to have 5. What's important is you don't get up here and cut all 5 of those off at the same point. You'll end up with a big step, and where this shingle comes down, it'll have a place where you start the water running sideways, which is not what you want a shingle to do. Shingles are made to have the water shed over them. They're what we call a discontinuous roof system, and they require gravity to stay sealed. If you were to turn this flat and put water on it, it would not be watertight. It has to have gravity. So what you want to do is stagger those layers as they come up. It doesn't matter which way you stagger it. I kind of like to put the bottom one a little bit less and each additional layer step up, but the important part is not to create that lump underneath of your tie-in where the shingles come down. You don't want anything that creates a long horizontal line that'll stop the water from flowing off the roof properly.
Great point. Now, Mike, as we're standing here, I'm looking and I'm seeing a potential problem here. We're looking at this valley right here, where there's a plumbing vent right through there. You'd like to walk over there and let's talk about that.
Here. Let's move some of the stuff out of the valley so we can see it.
Well, while he's pulling that away, if we could get a view right here. This is looks like bath fan venting right here. You can see the flex corrugated duct. This one is flex. This one looks like is 4-inch. This could be the dryer vent. One is an attic vent. But with this, they'll have to reinstall the ductwork that goes up into the vent. So they'll put a new vent on there, and that duct will go up into the vent. A lot of times, a lot of problems with roofing, and we come through a final inspection, we never get to see where the vents are originally. So where they're doing a final inspection, that's up to the roofer. He knows, he's there stripping the roof, he knows where those vents are, and it's his obligation to make sure those vents go back the way he found them and the way they were properly installed. So this is a case where they're going to have to bring the ductwork up and into the vent area as they put their new vent in. And then Mike has exposed part of the valley here where we can see where the plumbing vent is nearly close to the center of the valley. And Mike, what do you see, what's wrong with that?
Couple things. Back onto these vents real quick. Keep in mind, anytime you see this lint, you know that's a dryer vent. Mm-hmm. Dryer vents can't have a screen in them.
That's correct.
They can have a baffle. Unfortunately, the baffles get clogged up awful quick too and don't work very well. But you definitely don't want a screen, because if you put a screen on this, it's gonna take no time at all for this lint to collect in that screen and close this vent off completely, and your dryer won't work the way it should. And on a gas dryer, it can be quite an issue because they get very, very hot. If it is a gas dryer, you always want to watch what type of a flue you have coming through for the vent. It should be double-sided, but you also have to have some clearance around that double-sided vent. So you don't want on a gas vent for the wood to be touching the metal. You want a space between the wood and the metal on a gas vent.
Point, because that follows under the gas requirements in the building code. This is an existing installation, so a lot of times you're not going to meet current code with that because these homes were built under different code requirements. So, but this one here looks like it's a single wall vent. So it tells me this is probably an electric dryer. And so he's got plenty of opening here. So the vent just needs to make sure it comes up into the cap itself. So with that, that's what we're dealing with here. And we go back to the valley that I noticed, and you can see almost the center line of the valley. What do we have?
This is your valley, and a valley is where you've got 2 roof slopes terminating to an inside corner, and it creates what we call in roofing a valley. The problem with this particular valley is they've run a plumbing stack right up through the part of the valley we have to flash. It's not directly in the center of the valley, but it's still not a good condition. If conditions permit, my suggestion would be, and I think that's what Robert's planning on doing, is to cut this piece of sheathing out and do an offset in this vent and get it moved out of the valley. There are situations where you can't do that for one reason or the other. The vent is, you know, in a place where there's not enough room to offset it. So you have to use some special flashing techniques to deal with this, because you really have two details in one spot. And that's not typically something you're going to find how to properly flash that in the book or in the code. And that comes down to good roofing practice and having a good tradesman out on the job that can handle it. We can make this watertight, but we'd prefer it not be that close to the valley if possible.
It makes it harder to keep it rain tight, because you got most of the water running down the valley, and then we have a plumbing vent that penetrates up where the water's running down. So the proper way to do that would be to open that up and try to get that out of the way if they could. That's just moving the vent over PVC wise, as long as it's the same size piping material, then that would be the proper installation to do that, if they can move that out of the way. But sometimes, Mike, as you said, sometimes you can't do that, and therefore you have to really put the right flange on there and then seal it really well. And even then, it's not really a good installation because of what they have here. This was just typically a bad installation to begin with, but that's what we're dealing with an existing condition. So are we right, Robert?
Yeah.
You're going to try to move that vent over?
Yes, correct.
If you couldn't move it, the way you'd want to address that, because in roofing, we always work from the bottom up. And that way we keep the flow of the water working over the lap, not what we call bucking the lap, or the water running up against the lap where it can run under it. So what you'd really want to do here, if you had to leave this, is flash up to here, stop your valley flashing, get your valley flashing just up above this vent, then put the vent down. Now it'll be on top of this material below, and then pick up above this vent with your valley flashing again and continue it on. That's again, so you're not bucking water, or you're making sure that everything has a lap that flows with the flow of the water.
We've talked about a lot of portions of the house, and now we've come, since they're starting to do a dry end portion on the pitched roof, and over here, as we talked earlier about this eyebrow, which is a problem that happens, and because it's an existing installation and they have a wall siding over it, you can see there's lumber siding on the side of it, and then the eyebrow is up there. There's no L flashing or wall flashing where the eyebrow runs into the wall there. And then when the roof and the eave and the roof comes down on top of the lower deck, there's no flashing under there as well. So at that point, we're going to let Mike take over from there on what needs to be properly done to correct that.
Okay, as we talked about in the front, the code says that any place you have an interruption or a termination of the roof surface, you need to have a flashing. Now, that doesn't necessarily mean a metal flashing. There are several different kinds of flashings. There are roll flashings, there's metal flashings, and then there's membrane flashings. But it does say that it has to have a flashing. So here, there's not any type of flashing at all. They just butted their shingles up to the wood, probably put a little bit of plastic roof cement, which in and of itself doesn't represent flashing. So what you've got to do, and again, like we talked about up at the valley, in roofing, you always start at the bottom and work up. So we would want to put a piece of flashing in here, or up under here, one of the two. There is a little gap here, and if you could get it underneath, that would be acceptable too. But you have to have flashing here first, then here running up the soffit, because that's another termination. So you start down at the bottom, you'd run this next, overlapping this material, run that material clear up to the wall, and then run another piece of flashing over it, up, and in this case bring it out past this hole that's here and run it all the way up and butt it underneath of the soffit there and seal that off with sealant. And that's, again, that's an interruption, so it needs to have some type of a flashing there.
Right. And Mike, you could probably use some counter flashing there and caulk that as well.
I don't know that it's high enough to put a counter flashing in there. You just end up with too many materials in one little spot where it comes down to nothing here. You'd be a lot better off to use the soffit up above to terminate to, and then caulk that, because you're not going to have enough water running on this to create a problem. It's going to drop off. It's not going to be running on the underside of that soffit.
The situation there where we probably have a leak is through wind-driven rain, and of course we get a lot of storms here in Florida, so we want to try to head that off. So you know, as Mike was saying, we need to flash up under there and get it sealed, because of the wind-driven rain scenario. Normal rain would probably be okay, but it's when the wind pushes it and runs it up in there, it forces it. So, and that's when you'll have some leaking issues. So.
We talked about when we were down on the ground at the beginning of the video about spacing on the fastening for your underlayment. This underlayment is a 4-foot sheet. Most of the older underlayments we're working with are 36-inch sheet. So our table is for a 36-inch sheet, and that table says on a 36-inch underlayment, you're supposed to nail it 6 inches at the head lap. That's where one material laps over the other, 6 inches on center, and 2 rows in the field 12 inches apart. Well, that's for a 36-inch roll. This is a 48-inch roll. So we've got to add an additional row of nails in the field. Still 6 inches on the lap, but we've got to run 3 rows at 12 inches on center in the field to make up for the wider roll here.
As well as the lap.
And then 6 inches on center at the lap.
I've noticed in Mike that we have a difference in materials up here. Looks like we have is there plywood decking and 1x, or is that, no, that's 1x on 1x. So that creates a problem in the valley. I don't know if you can see it from here.
Yeah.
You see the difference in the height. The 1x on the deck, this pitch deck is coming up over the pitch deck on the other, so now we have a step down. So with that, it makes it very difficult to use the peel and stick there. So I believe, Mr. Wormley, you're going to put some metal down there prior, right?
Will you be using metal to give a proper transition, smooth transition? Go ahead.
What he's going to do, you're going to put probably a wide sheet of flashing there, flat metal, and run it up the valley, so he'll have a nice transitional from one deck to the other before he puts his peel and stick down in the valleys. Is that correct?
That's correct.
Okay. And then you want to take it from there, Mike?
Yeah, if you're using a metal valley, which of course is permissible for 2 different types of valleys. You can use a metal valley liner for both an open valley and a closed valley. So if you're going to use a metal valley, you don't have to put the metal underneath. You would just put your underlayment there and bridge that, and then when you put your metal valley, that would reinforce this step that's here. And that's one of the good things about a metal valley. It will help take care of some of the imperfections in the sheathing that you usually get in a valley. And that's one of the reasons we like metal valleys. And I think, didn't you mention, Robert, you were going to use a metal valley liner on this one? Yeah, so that'll cure that situation. You got to run his underlayment up and down the valley and have that underneath. But then once he starts building his valley up from there with metal, that'll take care of that transition in the wood where there's a step there.
You're going to use a closed valley on this, right?
Yes.
So he's just using metal for a base for the transition. First, he's got to run the underlayment from this deck up over the other deck. He's going to run that up. Then he's going to put his flat metal down, and then he'll run his valley liner in there. Is that what you're going to do?
Yeah, we'll run the valley metal. We'll run the felt up. Then we also run the metal. Then we will nail that metal properly.
Correct.
And then we seal both sides of that valley metal.
Correct. So it looks like he stopped short on his underlayment. He's going to have to run that up, and then the other layer will come up and run up over the valley on the other side.
Yeah, that liner will go.
So come up on the other side. So he's got plenty of underlayment there, and then he's going to put his metal flashing there in the valley, and then he'll run his I'm assuming you're going to use a peel and stick or a bitumen liner. What are you going to use?
Not with the metal.
Not with the metal.
You're just going to leave the metal and not put the modified in?
No.
Run your shingles. You're going to use a closed cut valley, right?
Right, without knowing what he was going to do, and you can do both ways.
Yes.
So that's why we wanted to talk about that. So he is going to just use the metal liner and not use a valley liner. So then but the proper way to do that is to make sure the underlayment is run under and up the next slope, and then he's going to put his metal over, and that will be his valley liner, and then he will apply his shingles after that.
That's correct.
In the code, there's 3 different ways to address valleys, type 1, 2, and 3. Type 3 is a closed valley using type 1 or 2 above, so without having those and reading them out. But you want to look at that if you're a contractor, or for that matter, an inspector, and realize there are 3 different ways to run your valleys, and you want to be familiar with all 3 because roofers will choose between those.
Okay, here we are on this front wall section here, and we're going to talk about the lumber siding material. The roofer is not going to remove that because he doesn't have the license to do the siding. So a lot of times, unless he's a building contractor himself, a lot of times roofers have that multi-licensing. But if they're strictly a roofing contractor, that's beyond the scope of their license to replace the siding. So what they'll do is try to reuse the wall flashing that's there. And as we can see going up the pitched roof area, there is L flashing there. And you can see the end of it, and you can kind of see where it's lapped. Now, but on the eyebrow area, there is no flashing there. And so that's an area where, like we were over on that other eyebrow, he's going to have to put flashing in there. And so, Mike, you want to take it from that as far as how to properly do that, and then once he's going to install the underlayment with that existing wall flashing. And how's he going to do that?
Okay. The difference between here and the other one we looked at is we've got a lot more wall condition before we get to the soffit. So if he runs a flashing in there, he will probably also have to run what we call a surface mount counter flashing, which will come and lap over the base flashing. The base flashing is shaped like an L. This flashing laps over it like this and then gets sealed to the siding with a caulk joint. Of course, the caulk joint is well up off the roof, so it's much better to have that up on the wall than it is down at the roof. On this existing siding, and the flashing under the existing siding, what they'll need to do is tear the shingles off, pull the underlayment, the old underlayment off, lift that vertical flange, or the horizontal flange, excuse me, on the base flashing up to get all the old material out from underneath of it, put their underlayment under the flange, put plastic roof cement, flashing cement underneath of the flange, nail the flange down 4 inches on center, and remembering not to get too many of your nails right back against the base of the flashing where you won't be able to seal it. And then once that's done, you're going to take some more plastic roof cement or flashing cement and a membrane and membrane that off to your underlayment, and then bring your shingles over that again in another layer of plastic roof cement. In Florida, we get tremendous rains. In a heavy, heavy thunderstorm rain, the water on this steep roof will get at least an inch deep at times. And so even though it's running off the roof, it's still very, very deep. And so you've got to seal those conditions, and those different layers, as we talked about with flashing cement or plastic cement in between, will seal that condition.
Wonderful. Mike, I want to really thank you for all the time you spent with us today. And Mr. Wormley, thank you for providing us a house to do our shoot today. This is a part 1 video. We wanted to do how it's properly done, from the stripping of the shingles to the renailing to the underlayment, and reinstall flashing, and also deal with the elements that we have to deal with, as well as we didn't talk about the skylight because the skylight wasn't here yet, but it is here now, and he's replacing it with the new code compliant product approval approved skylight. And so we'll check that at final for its fastening. And when we come back, we're going to do a final inspection of this roof, and this will really tell what kind of job has been done here. And this is going to be a really good educational tool for roofers to see a roof that's properly done. So with that, we'll end up today on our part 1 video, and we'll reconvene for part 2. Stay tuned.